So we're going to take a look now at Calculus 2. So the whole idea behind Calculus 2 is now the application of differentiation. So when we're differentiating, remember our first differentiate, if we have an original function, our first differentiate finds the rate of change of that function. And that's known as the first differentiate. Now, the first differentiate, the rate of change of a function, represents the slope. Okay, so that's what we're using that for. The rate of change of the function is how the function is changing. So in this video, we're going to take a look at increasing and decreasing functions and turning points and stationary points. So looking at this graph here, the first thing we need to figure out is when is this graph increasing and when is this graph decreasing? We read from left to right. So I'm starting on this side here, and I can see that the graph is increasing. So the graph goes up. Then it stops at the top, and we have what's called a turning point. So there's my turning point there at the top. It then continues and I begin to decrease until I get to this point down here on the bottom. And again, we have another turning point. And finally then our graph increases then up to the top here. So when we're talking about increasing functions, decreasing functions, remembering that we're dealing really with slopes in this, what we have here is we have in the first section, our first differentiate is bigger than 0. Why? Because our slope is a positive. If our slope is a positive, the slope is greater than 0, which means our first differentiate is greater than 0. Same for our first differentiate then, if we're talking about a decreasing function. If we're talking about a decreasing function, we're talking about our first differentiate being less than 0. So if we take a little look at what the functions, what the signs would be here, I have a plus slope, a plus slope, a plus slope, a plus slope. I then turn at this point here, and then I have minus slopes. So they're all going to be less than 0. And then again, I turn and I go back and I have plus slopes all this way here. So in the first kind of section of it, this section here, what we have here is that your first differentiate will be bigger than 0. In the green section in the middle, our first differentiate will be less than 0 because our slope is less than 0 because our slope is a negative number. And in our final section then, our first differentiate again will be greater than 0. Why? Because the slope is increasing, the graph is increasing, therefore my first differentiate is greater than 0. So now that we've seen that, let's take a look here then at our question. And this question here is we're given our function up at the top and we're given it as a graph. You can see here in the blue dots, they are the turning points. And what we have here is we have increasing function and increasing function. And in between the two then we have a decreasing function. So they can ask us to find when it's decreasing, meaning this section here. They can ask to find when it's increasing, meaning the two blue sections. Our first question here, what we're asked to do is we're asked to find when is the graph increasing. So the second you hear when is the graph increasing, when is f of x increasing, we're looking for what values of x do we have that this graph is going up rather than down. So we're talking about where the slope is a positive number, so the slope is bigger than 0. Slope representing the same thing as the first differentiate. So what we're going to do here is we're going to get our first differentiate and let it be greater than 0. So our first differentiate here is going to be the differentiate of this function here. It's 3x squared minus 12x plus 9. And I'm looking for when is that function greater than 0. So this is really what I'm using here. I'm using that and I'm using the same method as algebra to solve that. Now, because it's greater than, in this case, what we'll need to make sure we do is we'll need to make sure we do a graph at the end, a U-shaped graph to check and see are we going above or below. So it's something like this. We're going to just use our minus b formula to solve. And when we use our minus b formula, we'll get x is equal to 1 and x is equal to 3. Now we're going to try and use the fact that we're looking for ranges of values here. Now if I look at my actual graph, I can tell here that if I'm talking about the number 1, if I go that way from 1, my graph is increasing because it's increasing there. And if I go that way from 3, my graph is increasing there. So I know that from the graph, but if we're not given the graph, we have to be able to test it and see. And how I test it is I draw a version of this graph here with my 1 and my 3 and my U-shaped graph because it's a plus x squared. And I'm checking to see it's a greater than. So I'm looking for when is this function greater than 0. So there it's greater than 0 and there it's greater than 0, meaning it's above the x-axis greater than 0. So what I need to figure out then is, am I going to the left or to the right of 3? So here in this case, I'm going to the right of 3, which means I'm going greater than 3. And same then with this one, I'm going to the left of that 1, which means I'm going less than 1. So my answers here are going to be when x is less than 1 and when x is greater than 3. And I'm using this to find them, but we can see on our graph, if I go this way, if I use any x values from to the left of 1, my graph is increasing. If I use any x values to the right of 3, I'm also increasing. And that's what we're finding. We're finding x values where the graph is going up or going down. So there's my first answer. My second question then, that should be f of x. We're looking to find where it's turning or where it's stationary. Now usually here, that's a turning point. When we're increasing and decreasing, we only need x values. When we're getting a turning or a stationary point, that's a point like a coordinate. So we're going to need to have an x value and a y value. But we know that if I'm looking at the top at this function here, my function is increasing here. So there my slope is positive. I then get to the top where my slope is 0. I turn and my slope is negative. And then finally, I turn again and my slope is positive. So at those points where I turn at the blue dots, what we know is that the slope is not plus, it's not minus, it is actually equal to 0. So if I know my slope is equal to 0, that's my first differentiate is equal to 0. So a turning point, a stationary point, or maximum minimum, what we're talking about there is my first differentiate is equal to 0. The graph is not increasing, it's not decreasing, it's actually doing nothing. It's going from increasing to decreasing, so the slope is 0. So again, when we're talking about our first differentiate, we have it above, it's 3x squared minus 12x plus 9. I'm now equaling it to 0, and this is the question that I'm answering. And again, we use minus b formula there. We've already done it above, and I got values x is equal to 1 and x equal to 3. So they're my turning points. And you can see in the graph, it is where x is 1 and x is 3. But because they're asking me for a point, they are the x coordinate. I now need to get the other coordinate, the y coordinate. And how do I do that? I fill in where I have y equals, which is this up here on the top left. So if I have x, I can fill in f of x so that I can end up getting what y is. So fill it into the original to get y, fill it into the first differentiate to get slope. So if I fill in f of 1 here, that's 1 cubed minus 6 times 1 plus 9 times 1, I end up getting the number 4. So that is the coordinate 1, 4. If I fill in 3, I'll have 3 to the power of 3 minus 6 to the power of 3 plus 9 times 3 is equal to, and I fill it in the calculator, I get 0. And that's 3 and 0. They're my two coordinates. And again, if I check my graph, it is 3 and 0. That coordinate there is 1, 4, and that coordinate there is 3, 0. So we know we're right. But again, we're not going to be always given that graph there, but it's nice to see that when you're doing the maths, it correlates to the graph that you're being given. And that's how you find your turning points, your stationary points, your maximum points, your minimum points, and if the graph is increasing, decreasing being the same, you're just using a less than instead of a greater than. In the next video then we'll take a little look at determining the nature of these turning points, so determining if it's a maximum we have or if it's a minimum.